Hello, my name is Jorge La Puerta. My topic is serviceability, limit state, deflection, and cracks in reinforced concrete. Serviceability, limit state refer to the performance of a structure under normal service load and are related to the use and or occupancy of the structure. The serviceability state, limit state is measured by considering the magnitude of deflection, cracks, and vibration of the structure. Importance of deflection. Excessive deflection in beams and slabs can cause sagging floors. Models in flat roofs, excessive vibration. Such deflection can damage partition, walls, and disrupt the close of doors and windows. There are deflection in single beams and continuous beam. Deflection control. One of the best way to reduce deflection to increase the camber of the members, but designer prefer to design a low camber because it means thinner floors, and thinner floors mean thinner building. Thinner floors mean lower building height and lower building cost. Deflection calculation. It can be seen that deflection at the center of the span of a simply support beam with uniformly distributed load is 5 times greater than the deflection of the same beam if its ends are inverted. Almost all concrete beams and slabs are continuous, and their deflection has intermediate magnitudes between the two ends. The picture, I can see the deflection equation are the following variable are letter W, uniformly distributed load, letter P, point load, letter L, length of the structure, letter E, modulus of elasticity, letter I, moment of inertia. Effective moment of inertia is called IE, the effective moment of inertia, and is based on an estimate of the probable amount the cracking caused by the variable moment along the span. Long-term deflection. Factors that affect increase in deflection are moisture, temperature, curing condition, compressive steel content, stress to strength reduce, and the age of the concrete at the time the load is applied. The steps involved in the calculation of instantaneous and long-term deflection can be summarized as follows. Letter A, calculate the instantaneous or short-term deflection for the load only. Letter B, calculate the instantaneous deflection for the load plus total life load. Letter C, determine the instantaneous deflection for total life load only. Letter D, calculate the instantaneous deflection for the load plus the permanent part of the life load. Letter E, determine the instantaneous deflection for the permanent part of the life load. Letter F, determine the long-term deflection for the load plus the permanent part of the life load. Types of cracks. Flexural cracks are vertical cracks extending for the tension size of the beams to the region of their neutral axis. In inclined cracks because shear stress may develop in the web's reinforced concrete beams as either as the independent cracks or as extension of flexural cracks. These are divided into web shear cracks that sometimes occur in the B webs of pre-stressed sections. Shear flexural cracks develop in both press pre-stressed and unpressed beams. Torsional cracks describe spiral paths around the beam. Cracks occur in reinforced concrete structure because the long tensile strength of concrete with the use of high strength rods and the extreme design method. Cracks control has become a very important aspect of design. Smaller cracks will occur if several small rods with moderate spacing are used instead of a few large rows with large spacing. Where letter W estimate cracks with the 1,000th of an inch, BH radius of the distance to the neutral axis from the extreme tensile fiber of the concrete to the centroid of the tension steel. Fs stress in steel, DC overlap of the outermost rebar measure from the extreme tension fiber to the center of the rebar or the center of the steel to the center of the nearest rod or wire. Letter A, effective area in tension of the concrete around the main reinforcement. AC code standard for cracks. AC code requires that the flexural tension reinforcement be well distributed within the maximum stress zone, such that the center-to-center spacing of the reinforcement close to the maximum stress surface is nearest reinforcement to a tension surface is not greater than the value calculate with the following expression. Miscellaneous cracks, it is possible to include a few reinforcing routes that determine location in some structure, even if there seems to be no theoretical need for them. Thanks.